let's jump into this. Going to kind of go through this really quickly because Jared, I'm sure, knows a lot of this already. Why? What is it? Here's some different definitions from different organizations and researchers. And kind of a common theme is the use of technologies to maximize our input, maximize the efficiency of our inputs, and hopefully increase our profitability in doing so. So these are similar. This one expands it a little bit to more of an ecological level, using ecologically based principles, genetics, and all of the tools we have available from the American Society of Agronomy Precision Agricultural Systems Group. There is an organization, International Society of Precision Agriculture, and this is their definition. Again, management strategy that takes into account temporal and spatial variability to improve resource use efficiency, productivity, and all of those things. So you all know that. A lot of different ways to use precision ag, from just basic GPS guided steering, which I really wish I had when I was a kid. I lost a lot of sleep over the crooked rows I made. To yield mapping, field scouting, remote sensing, satellite imagery, drone technology, equipment mounted sensors, and then variable rate applying a lot of these inputs. Some things here we haven't explored a whole lot. Variable rate seeding is something that has been talked about over the years, but I don't know that anybody's done a whole lot with that. But certainly nutrient application, irrigation, and pesticide application are receiving a lot of interest. So it's been kind of an interesting thing to be involved in this. You know, we've been talking about precision farming for 30 years probably. We've had some pretty cool technology developments over that time. But kind of finding out what that intersection with the agronomy is, and you know, getting the agronomy up to speed with the technology has been a little bit of a challenge. But pretty cool technology based on the satellite system that we have in place, and readily available now, which is really nice. Again, the technological developments have been impressive, and they keep getting better and better. A lot of technologies out there, ways to collect spatial data, yield monitors. You guys do yield monitoring? No? Don't have a yield monitor on the combine? Well, we did a little bit of work here in Powell with sugar beet yield monitoring. Doesn't work so well, too much mud. But with grain systems, works pretty well. How about electrical conductivity sensors? A Vera system or an electromagnetic system like an EM38? Anybody aware of those kind of technologies? This is our unit, a Veris electroconductivity mapper. Just straight coulters, 2 sets of them. One's an anode, one's a cathode, sends electromagnetic energy through the soil and measures how conductive the soil is. And that's correlated to things like soil texture, soil moisture, salinity, and things that conduct electricity. So it can provide some pretty useful spatial information on a really fine scale. Satellite imagery. Anybody use satellite imagery? There are some services that provide it. Drones. Anybody find drones around here? Got a few people in our area that do for crops. On-the-go sensors, Green Seeker. Anybody heard of Green Seeker or done anything with it? It collects light reflectance data and calculates an NDVI. vegetation index, can't remember what the ND stands for, and could provide some really good information as well. Often used in relationship to nitrogen status, that can map other things as well. Okay. So some tools out there that we can use to map things. Okay. Technology is doing some wonderful things. And then, of course, we take that to the field with the irrigator or the air seeder or the applicator equipment with the GPS technology. You guys are very familiar with that. Pretty advanced technology. Sure beats the technology we had when I was a kid. This was our variable rate fertilizer applicator. All right, so we talked about some of the potential data sources. Haven't talked about soil testing yet. That's an important one. We're going to spend most of our time on that. And again, different inputs that we can use that technology with. Here's a system diagram for fertilizer variable rate application with your rate controller, ground speed indicator, regulators, and servo valves, flow meters. They left out the GPS. That's kind of an important part. Anyway, that's how the system works. And of course, you can come up with all kinds of visions of, an integrated modern precision farming system that includes everything from controlling your irrigation system, planting, installing your drain tiles, keeping track of your trucks, soil sampling and field scouting. And I think that's a sprayer out there. So, electronics are wonderful, right? And they never mess up. So they look pretty cool. Unless you have a bad satellite day, then you have problems. All right, so one point I really want to kind of emphasize here, the importance of generating good information to base your variable rate application on. So precision farming is, we like to define it as putting the right amount of whatever input it is, the precise amount in precisely the right place, right? I think we're getting pretty good at putting things in the right place with the GPS technology. But do we know how to figure out what the right amount is for each of those locations in the field? I think that's where the challenge is. Am I right? We're getting better at it, but there are some challenges. So we don't want to be putting precisely the wrong amount of input in precisely the right place, right? All right, so generating a map is a key to this. And Jared, you probably got some pretty good insights into how to do this. What kind of a map did you use, just based on soil sampling? Oh, they did. Okay. Okay. So Simplot ran over it with the Vera CC meter. That kind of fleshes out some fine detail, and then they determine some zones and sample those separately. Okay, good. This is a map, a nitrogen urea application map from a study that was done in Sidney before I got there in the mid-90s. About an 80-acre field. I know you can't read any of that, but shows the prescribed nitrogen application rates for this field, where red indicates up to about 340 pounds of urea. Okay, and then all the way down to 0 on the green end. There aren't very many spots there, but realistically down to about 200 pounds of urea or 100 pounds of available nitrogen in the yellow areas. So there's some variability there. And they applied that fertilizer with a variable rate applicator, and on 7, 8, 10 different fields throughout eastern Montana, And I'll show you kind of a synopsis of the results here in just a minute. You know, that map is crucial. They also had that done by the co-op in Edgar. So those services are available. So yield monitoring data is something that we can use in creating a map, remote sensing data, as I've mentioned, but also some soil sampling strategies I wanted to talk about, pluses and minuses of the different strategies. So I'm going to refer to others' work here and other publications. And the first is a publication out of North Carolina State University. And you think, oh, well, that's way out on the East Coast, doesn't apply to us. But these principles, I think, are applicable regardless of where you are. But they discuss in an extension bulletin a few different approaches to a soil sampling scheme for coming up with a map. Jared, right? Correct me if I get it wrong. You know, you use this zone sampling procedure that is illustrated on the far right here. You know, this field shaped like a pear, divided into 3 zones. How many zones did you have? 3. Okay, it's a good number. Now they talked about some other schemes as well. Now this is probably the other one you're most familiar with, which is taking soil samples on a grid pattern every so many feet. And how many feet that is something we're going to talk about a little bit here. But for here, you're collecting and analyzing 3 samples here. You're looking at about what, 30 plus samples there that you need to collect and pay to have analyzed. So the big advantage to zones is lower analysis and sampling costs. You knew that. Now here's another approach that I thought was a little interesting. I haven't really seen this one discussed a lot, but they're suggesting that rather than just taking a point sample on a grid here, divide your field up into smaller sections of various sizes. Could be 2.5 acres, could be 5 acres, could be 1 acre if you want. And then take a good uniform sample from throughout that area and have that analyzed. So you're treating each of those blocks as a smaller field. So you're fertilizing it on a 2.5 acre basis. So rather than, you know, where with these others approach, you get kind of a continuous map, right? So that was an interesting approach. Might be a little bit of a compromise between some of these. And so this shows that block and the sampling pattern within the block, trying to represent that whole area and treating it as a unit. So the difference with this approach is that we try to characterize that point on the grid the best we can. What is the nutrient availability at that point? So where here we're going out, you know, hundreds of feet from the center of that cell. Here we're concentrating within the 15 to 30 foot area of that soil and taking 5, 10 cores out of there and compositing them. So why do that instead of just 1 core? No matter how much we would like to believe that the soil properties are uniform, they're not. And you can hit hot spots or dry spots. And really to get the best soil sample you can, should be a little bit of a composite of the area around that point. Now, with this information, then, you take that into a software program that will estimate soil test levels in between those grid points and produce a continuous map. Okay, make sense? All right. So grid point sampling has its benefits and drawbacks. It's probably the best for capturing some of the more fine detail in your nutrient patterns, depending on how far apart you space those sampling points. Typically, over the years, it seems like 2.5 acre grids is kind of the go-to. maybe because that's barely affordable, or sometimes it's affordable, sometimes it's not. Some people like to go 5-acre grids. Researchers will say that's probably not giving you as good information as you want. And kind of, for those who have really looked into this, a 1-acre grid really gives you the best information. That's a lot of information. Now I'm going to draw some of this information too from a researcher at North Dakota State University, a little closer to home, Dave Franson. Great guy, came out of the fertilizer industry and got his PhD and does soil fertility work in North Dakota, has for many years. And he's worked a lot on these sampling strategies. And he said, you know, there's a place for grid sampling. If you're going to do it, you want to do it right. And he said, do it on a 1-acre grid. So let's talk a little bit about that. Where does that number come from? 1 acre, 2.5 acres. Well, it's mathematical and statistical. It's not just pulling a number out of the air. And scientists have done some pretty intensive sampling of fields over the years and done statistical analyses on those samples. And they generate a graph that looks like this. It's called a semivariable graph. I won't go into why it's called that or what everything on here means, but I just want to show you the principle here. So across the bottom here is the distance from your sampling point to the next sampling point. Okay, so this has some numbers here. Let's say they're meters. We can do feet if that works better too, but meters probably makes more sense. So we go out 10 meters, 20, 30, 40. So we have these different sampling points along here. So some just a few feet away, and then getting out to quite a long ways away, 100 feet. Now they do their statistical procedures, and based on the variance of those samples from one point to another, they use this, they generate this graph to find out how closely related those sample points are to each other. What you really want is for this sample here at this grid point to be somewhat related to the next one you take and somewhat related to the next one after that. So as you fill in that information in between those points, it kind of follows a continuum. Okay, if you get too far away, they have no correlation to each other, then that information in between probably not accurate. Okay? So the lower this number on this scale, the more related those samples are. So makes sense. The closer we are to 0.0 here, if we're measuring phosphorus, for instance, the more likely it is that the soil test level 10 feet away from you is going to be kind of like this one here. And then if I go to the next one, I hope to start seeing a pattern. Yeah, go ahead, Mike. Yep. Absolutely. Thank you for reminding me, Jeremiah. I appreciate that. So in the field, we have different fields, different variability, different amounts of variability. We can obviously see that in some cases. I guess we might be surprised sometimes at how much variability there is in the field that doesn't look like it does, or vice versa. But absolutely, that is a driving force in how accurate these maps are. Now, it's kind of hard to know what kind of variability you've got unless you have some kind of a measure of that. This is one way to do that. They're probably the best. So yeah, it absolutely has an impact, and maybe that'll kind of follow up or tie into something I'm going to say a little bit later. I hope so. For an approach to how to use this. So back to this, when we get out to this point, which they define as the sill, we're starting to lose that correlation. So we want our grid points to be within this range. Okay, and based on research that I've looked at, this number can be, or is usually between 100 and 200 feet. Okay, so if you're going from this point 200 feet out, When you make a square out of that, how big is that? It's an acre, 208 feet on the side, right? Basically. So if you're back at 100 feet, that's a fourth the size. So you're getting pretty intense. I don't think anybody wants to take 4 samples per acre, but that's what the science is. Okay. And to Mike's point, that varies hugely from field to field. So you can't really do a one size fits all. But that's where these numbers are coming from. Okay. And I'm assuming that there are some cases where 2.5 acres fits within those parameters. All right. So grid sampling. Here's some maps from the field in Illinois, 40 acres, showing the stability of some of these patterns over time. This is for phosphorus, first done in 1982, and then again in 1991. We're seeing some of the same patterns here. Actually, looks like maybe more variability with time, contrary to Jared, so maybe they're not doing something right. And I don't know if they're doing variable rate on this or not. But the point is, somewhat repeated for some of these nutrients. Now, if you did this for nitrogen, probably wouldn't see the stability, just more mobile. All right, so this is how they did it. Really intensive sampling, and 7 per acre, and then they compared that as a standard to 1, 2.5, and 5 acre grids. And this number here kind of shows you how well each of these correlated to that really intensive sampling. So even on a 1 acre grid, we're only about 50% effective. Okay. If you get out to 5 acres, not doing so good. So it does make a difference. Just keep that in mind. All right, so grid point sampling. The study we did they did in Eastern Montana before I got there. Here's a K application map, and then gross returns from that field that I showed you earlier. So we do see some variability. P and K much less than with the nitrogen. Here are some of the things that they found. This was a 1 acre grid pattern that they used, and sugar beets were grown. They also grew corn. And estimated gross profits increased by an average of $112 per acre for the sugar beet crop, net profit 75. However, of all the fields that they did, not all of them showed these things. I'm talking with Dave Franson over at North Dakota State University. He says they're having pretty good returns on variable rate application of N in the Red River Valley. So he's a proponent of it. And in particular, P and K, could show some benefits as well. But certainly nitrogen is going to have a bigger impact if we can manage it correctly. All right, just another illustration here. One way some researchers use this grid sampling on an intensive scale to look at something. They did a grid sampling on a field, had an area where there's something weird going on. And they went in and then sampled it really intensively on a grid pattern. This is only 140 feet across on the square. And they took a lot of samples in there every 8 feet and found out that they had this pattern in that area. They've got streaks of low and streaks of high phosphorus across their repeating pattern. Somebody had an each with a fertilizer applicator, probably, right? or maybe there were corrals in there and these were the alleyways. I don't know. Could be. But again, that's pretty fine detail if you really get down to it. It shows you what grid sampling can do. Not that it's practical on a 40 acre basis. All right, so benefits of grid sampling: captures the soil patterns probably better than some of the other options. Does capture them better. The grid density question is certainly an issue to grapple with. The economics concerned with that. That's a disadvantage. High sampling and analysis costs. So pluses and minuses. That cost is a pretty big minus. All right, so let's talk about zone sampling for a minute. Jared's had good luck with this, and I guess as far as we're concerned, and talking with Ray Franson, he agrees zone sampling definitely has a place in what we do. Dave's been a big proponent of it over the years and has done a lot of research on it and kind of refined some of the procedures that they've used. I'm going to put this up on the last slide, but he actually has 3 extension bulletins on his website. If you go to NDSU and look him up, they're related to variable rate technology and developing maps. So good information there. He does a really good job. In his part of the country, the first level of information they look at is topography. Our fields have all been pretty much leveled flat, right? So we don't have high spots and low spots. But there they have knobs that have been eroded off and swales that have collected some of that sediment. So you'd expect them to respond a little differently to fertilizer. So that's kind of their first step in generating a zone map. Here, instead of that, maybe if you've had a field that's been leveled, that'd be a good place to start. Where was the cut? Where was the fill? Those kind of things. So some quick and dirty things. And then you can get into the more technical options to kind of combine that information together and create a map where you can delineate some zones. Combining, really, Dave's recommendation is that you combine lots of levels of information. In order to do that, you've got to have the software to do it. I don't have it at home. I don't have it in my office, but there are dealers and consultants that do. So that's kind of the ideal. He likes to look at yield maps as well, but not just 1 year. Too many weird things can happen in a given year. So he says, look at least 2 or 3 years, see if there's any stable patterns that repeat themselves year after year. And you kind of look at those as your zones. And I think that's a really good tool because really what we're after is getting our yield where we want it to be. These nutrient levels and everything else contribute to that. But, we might need to manage zones differently based on their yield potential as well. So he says 2 to 6 zones per field, 40 to several hundred acres. So maybe you're right in the ballpark as far as he's concerned. And that makes sense. You get too many zones and you lose your advantage of zone sampling. He said some people have gone as high as 10, but you kind of make a lot of work for yourself in that case. But might be worth it if you have a field that would require that. So you sample each zone as if it was a separate field, representative composite samples. And I want to emphasize the importance of getting a good sample. I mean, whatever way you decide to generate a nutrient level map, if you don't take good samples, then it's all wasted up. Make sure you use good soil sampling procedures. And Dave mentioned that this might be a good option for nitrogen, more so than the good sampling. All right, so here's just a couple of examples of some data layers that we've collected. I showed you this field several times before. This is the corn yield map. So we're seeing some areas where we have low yield and some pretty high yield as well. So pretty fine resolution on that. Here's some imagery, satellite imagery of a field in Illinois. You see some patterns there. This is the NDVI, so kind of a crop health status measurement. I'm assuming the darker green is a more healthy crop. The lighter green is less so. You can see some patterns here. Looks a little better in the middle and some areas around the edge that aren't so good. And then up here, it looks quite a bit different. This is a different variety from what the information said. This is the same field with a green seeker mounted on the tractor or something. So you're on the ground and really getting much more detailed information. So the different technologies have different advantages. All right. And then this is a map that we generated on our research site in Sidney using the Veris system, the electrical conductivity mapper. About 10 acres, maybe 12. Well, probably closer to 10 in this map. And we have, varying from green to red, different levels of electrical conductivity. This is a gravel bar in the middle. So it's picking that up. And you can pick some of that out because you can see rocks on the surface, but this gives them a more refined measure of that. And then in the boxes here, we have barley yield that we collected on a per plot basis. And so red and orange and yellow are lower yields than green. Definitely a correlation. All right, so just a couple of things to summarize here. On zone sampling, advantages that it sure saves some money and is easier than the good sampling approach. Best results when you combine some of those data layers, according to Dave. Then might make sense for site-specific end management in particular. Here's a little bit of data showing the benefit of combining these technologies. Again, this is out of North Dakota, I believe. And this value here in 2 different years, the bigger this number, or the closer to 1 it is, the better map it's doing. Okay? So when we just look at topography combined with electrical conductivity, we're at about 0.44, 0.4 on average, let's say, over the 2 years. We add satellite imagery into that, helps out a little bit. Yield map didn't really help, I guess, compared to the satellite imagery. And then topography, yield, and satellite was the best in this. Just showing how those layers can add and benefit each other. All right. This is out of a publication, extension publication from North Carolina State that I mentioned. Talks about some of the advantages and disadvantages of these different methods and the number of soil samples that you need to collect. We've already gone over these pretty much. It really comes down to cost and accuracy. So weighing off those, or weighing those benefits and disadvantages. So in terms of grid sampling, again, probably the best way to characterize that variability. But how far apart do those samples need to be, and how much can we afford to pay for that? However, as I kind of demonstrated that over time, those patterns are pretty stable. So we don't need to do it. Maybe every 5 years, maybe every 10 years, kind of depends on what other options you have available. Gone over the benefits and disadvantages of zone sampling, different data layers. So just a few final thoughts to wrap up. How am I doing for time, John? Better than the last one? All right, good. All right, so variable rate fertilizer application has been shown to be economically beneficial. Mentioned that, but it's case-by-case basis. Some fields it's just not going to pay out. And a big part of that is how much variability you've got in there. Largest potential returns really are from nitrogen. I don't want to discount the phosphorus and potassium. Those are important too, but N has the most immediate and probably the biggest impact on your bottom line. Creating an accurate application map is critical. Gone over this stuff already. So no particular sampling scheme is necessarily best in all situations. And maybe combination of. So just a suggestion, and this kind of comes from Dave Franson. If you really think that this is going to be a thing you want to do over a number of years, make that investment, do a grid sample the first year, and get those patterns established, and then use that and the other information to create your zones, and then do zone sampling in subsequent years. Now, kind of back to Jared's experience, you want to monitor those soil test levels and see if you're evening things out. See if you're seeing some patterns develop that are kind of weird, that might suggest you want to do some grid sampling. Maybe not the whole field, but target it to areas of concern. Would certainly be a possibility. And then if it looks like things are evening out, like Jared said, maybe you're good for a while. You don't need to go with the variable rate. So that's one suggestion, kind of combine everything together. So as I mentioned, resources are available for better and more detailed information than what I've given you. And these are a couple of those resources. I printed copies of Dave Franson's 3 for me. You can come and take a glance at them. I was selfish and I didn't print any out for you, so I'm sorry about that. And then if you get online at North Carolina State University, you should be able to find that one as well. I found it this morning, so it was still there this morning. Good discussion and good concepts to think about it in this presentation. So with that, thank you for your attention and patience, and